So today is day 5 of 30. We'll see how that turns out. And there's a couple of things I wanted to talk about today. And I like being old school with certain things. So here's a physical piece of paper that I track each day. I've been doing this for years now, but it's just nice to see that I've still got that momentum. But there's one other thing I wanted to talk about, more related to the product itself. And it's related to or building upon some of the workflows that I talked about a few days ago. So yesterday I mentioned that there's this opportunity to potentially work with a client and do some, and the way that we're going about it is I'm using this as an experiment to test out one of the architectures I'm proposing for the app. And the way that you can go about building workflows, there's many different approaches, but you can have, and I'll just use two examples here. Let's say we've got workflow 1 and workflow 2. And like I mentioned the other day, the way that you manage memory and context across different stages of a workflow really determines the impact, and there's pros and cons of each of those. We'll go with workflow 1, where we'll take a simpler approach from an agent perspective, and we'll use or manage memory in a slightly different way. And that'll be our solo agent. And for the purpose of this, we'll just have a duo, or that could be multiple as well. So with a solo agent, we have one agent which is defined. In the duo, we have 2 agents. And in this case, an agent is basically a call to a model with a specific prompt, and that can manage some of its own context as well. Now, if we have one agent and we're going through a complex workflow, that agent has to be adaptable to take on many different sort of personas as it goes through that task. So we may have a initial creation step. So let's say it's a step 1, create, and then that may have some inputs, and then we'll also have some outputs on the other end, and that'll be V1. And then we may have another step, so that'll be S2, and this will be to review. And off of that, there may be some pass-fail conditions. So we'll say that there's some pass here, there's a fail here. And this can be quantified in a bunch of different ways. It could be the model saying, hey, this isn't good enough, you need to go and do it again. Or it can also be sort of just using a normal logic, like saying, hey, this is too long, there's too many characters, or there's too many words, too many sentences, go and make it shorter. Or the inverse as well, make it longer. And with this pass-fail, along with that, you can pass those reasons on to why something has failed, or say this is passed for these other reasons. Now, when we use a solo agent, when we've got that fail, we can pass that back to the exact same step in the process that actually created that initial output. So you can think of this as having a single agent, and this is similar to if you're having a chat with ChatGPT, where you may have a single chat window and you say, hey, make me this thing. This is you, make me this thing. And then the chat window goes back and says, okay, here you go. And as that comes back, you might then look at it and say, actually, fix this. And then it's like, okay, here you go. And all of this is in a single chat. And that's sort of what we've got, is a single agent in this sort of example. We go from having a single, the analogy is to have a single chat window, similar to if you're using a normal model like ChatGPT or something that you use in the browser. The big benefits of this approach is that memory across these steps is retained. One thing to add, at each of these steps, even though we're using the same agent, we can provide slightly different prompts. So for that first one, we just start the process, and that would be our create. We say, hey, create me this thing. And then it goes off, does the thing. And then on that review step, we can send back to that same chat, instead of saying, hey, create me something, review this thing that's already been created. And then we can get that feedback and then ask it to recreate if it isn't good enough. So the big benefit is that the memory is retained all in a single chat window, if you want to use that mental model. But then the downside is that you've got the same model doing multiple tasks, so there's less specialization. And this is potentially a bad thing if you want some things that are really complex and you want a lot of information. But there's some really sophisticated systems that are using a single agent approach like this and just managing the information that it uses at different steps in the process. So that's option one. And you can imagine with each iteration, you get some of this building up. So you can get some pretty hefty context here if you have many different turns in a process. The other option, where you've got two agents, you may have a different agent for step one and step two. So you've still got the same input that's coming in. In step one, we've got create, and that's going to be by agent one. So that's agent one. And agent one here is different to agent one here in that it is specialized on just that creation step. So you're just focused on, hey, you're going to get some information and you're going to create something. We then pass that to step two, and this will be our review step. And the difference here again is that we're going to agent two this time. And with agent two, your only focus is review and provide feedback. You don't actually create or action anything. And then you can have a similar pass-fail condition here. And then if something fails, you then pass it back. And if it passes, you let it roll on through. Now, the mental model here is that you've got two different chat windows and you're passing information between them. Sort of like two different people. Now, there's benefits of having two different people for certain tasks, particularly complex things, because you can have each person focused on one of their things, one of their purposes, one of their outcomes. But the downside is that when I ask you to do something, quite oftentimes I will know a lot of the history and reasoning and rationale behind why I asked you to do something that I may not or may take for granted when I ask you to do that task for me. So then sometimes you might come back and ask me for a bit more clarification, or you might go off and do something, and then it's only when I see the output that I realize, I forgot to tell you that we needed to make all of the boxes purple. Can you go off and do that again for me, please? That's the downside of having multiple specialized agent approach. You lose some of that context each time, and then it sort of has to get assumed by the other person or the other agent of what was intended by that step. So let's go with an example here. So we've got our first chat window, so this is create, and in our second chat window we've got review, and it's the same process initially. Hey, create me a thing, and that's me, and then it's like, okay, let's go off and do that. Here you go. And now, whereas in this, the feedback was within the same environment, this output then gets passed over and says, it's like forwarding an email and say, hey, can you review this? Go off and review that, and then here's your feedback. And now this feedback actually needs to get tossed back over here and say, please fix. And then you say, okay. And you go off and do that again. And so while this approach maintains everything in one place and is quite linear in that sense, here we've got multiple different specialized agents that are passing information between each other. Now, there is, of course, ways of consolidating all of this, and even with different specialized agents, sending all of the relevant information back and forth, but it does take a bit more thought on how to do that, and in a way that is scalable and maintainable. So the reason that I wanted to bring this up is that there is no best practice for some of this stuff yet. Now, there's huge companies that are taking the multi-agent approach, and with Anthropic, they're going this way with the paper that they released recently on best practice for making agents. And there's other huge companies that are taking a single agent approach, like Devin or or the company that's making the AI coding agent, Devin, and they're managing a lot of this with a single agent. Then they're just doing really sophisticated stuff to manage the context and managing the information that's available to that model as it's going through the process. So what we're going to test with this client is we're going to test Solo. We're going here mainly because of the benefits in terms of simplicity and memory management, and just to see if we can get something good enough with fewer, more specialized agents. And it might be that we do 80% with a single agent, and then we maybe shoot off to a slightly more specialized agent for some of the refinements at the end, and you might do something like a 80% for one of the agents, 20% for the other. But there's so many different permutations of this, it's difficult to say which is going to be the right one for what the type of outputs that we're trying to create. But the only way that we can test this is by getting real scenarios that we're fortunate enough to have in front of us here. But anyway, those are two things that have been on my mind. I'll leave it there and I will see you tomorrow.